Okay, so I'm quickly going to go over this question from the handout, one of the practice questions. This is practice question 5. And so there's the question: is determined that a sample of copper 1 acetate is comprised of that many total atoms. What is the mass of this sample of copper 1 acetate? So the important bit of information here to recognize is this total atoms. Okay, so total atoms is not the chemical entity. The chemical entity we want to deal with is copper 1 acetate. That's a formula. So let's get the formula first. So copper 1 acetate has a formula of Cu, C2H3O2. And if we wanted to determine the molar mass of that, we'd plug it into the calculator. So molar mass of equals, and it turns out to be 122.60 grams per mole. You pretty well always need a molar mass, so you might as well go ahead and calculate that right away. Now, so back to this total atoms. So total atoms means we basically have a bucket full of atoms. We're not distinguishing whether they're copper, carbon, hydrogen, or oxygen. It's just a bucket of atoms. So let's look at this first of all. What's it made up of? Well, it's made up of 1 copper atom. It's made up of 2 carbon atoms. It's made up of 3 hydrogen atoms, and it's made up of 2 oxygen atoms. So in terms of atoms, copper 1 acetate is made up of 8 atoms in total. That is to say, this formula unit, that's our chemical entity. This formula unit made up of 8 atoms. So that becomes a conversion factor. The conversion factor is the relationship between 1 formula unit and 8 atoms. So our first step in this problem is to get to our chemical entity. This is the chemical entity we want to get to, and this is what we need to use to get there. So what we're looking for, formula units, equals what we're given, total atoms, times our conversion factor. And so how many atoms do we have? 9.65 times 10 to the 24th atoms. We want to end up with formula units, and we want to get rid of atoms because we want atoms to divide out. So 1 formula unit per 8 atoms. What divides out? Atoms. And so we're left with 1.206 times 10 to the 24th formula units. So again, it's important here you realize the chemical entity in the Avogadro constant is that sort of larger or bigger entity we want to use when we go from moles to number of particles, or vice versa. In this case, we want to go from entities, but total atoms isn't the entity because it doesn't distinguish. So what we have to get is formula. We can't get a molecular mass for total atoms. We need to get a molecular mass for our copper 1 acetate. That's our chemical entity. So before we do that, we have to get the formula units of copper 1 acetate, and we've done that. And so now we can carry on with the rest of the problem, and it's pretty straightforward once we have figured out the number of formulas. We're going to do this in one step. So we're looking for a mass. Mass equals number of formula units divided by the Avogadro constant, because we're going from a very large number of formula units to a smaller number of moles, times the molar mass of copper 1 acetate. And so the number of formula units was, we just calculated that as 1.206 times 10 to the 24th formula units divided by the Avogadro constant, that's 6.022 times 10 to the 23rd, 4 millionths per mole, times the molecular mass of copper 1 acetate, which we calculated as 122.60 grams per mole. And so moles divide out, 4 millionths divide out. Again, what are we looking for? Mass, and that's the only unit left. We've rationalized our unit, so we know we're going to be right. If we plug it into the calculator, we get 245 grams. So, again, the starting point in this problem was maybe the tricky part, but remember, you have to be able to get to some sort of chemical entity, formula units or molecules. Just because you're given a number of atoms doesn't mean you can't get there. It might require a step with a conversion factor.